It is my duty to acknowledge Carl, Steve from Sealord and Volker for their continuing support from the co-investor companies to make this all happen. So thank you again to them. To the Primary Growth Partnership panel, and I know there's a few of them here, again our acknowledgements to them. It's been fantastic support from them. And the continued dedication from Alistair and Susie and their team at Plant and Food. So just to put it into context, and I know Eric's going to blow me up, he's seen half of this before at the Snapper Strategy Group, but we're 3 years into the program. It's a staged development. We've got a lot of work in front of us, but we're setting up a very, very pleasing platform to work our progression on from. So we're establishing great potential for the work. As we've said, we've got 3 co-investor companies, Aotearoa Fisheries, Sealord and Sanford. We've got great support from the scientists at Plant and Food, and we've got tremendous support from the Primary Growth Partnership team. We've got the modular harvest system, which is the core technology. This is a membrane-based system, and primarily what it's doing, it's reducing the water velocity inside the trawl environment. We've got 3 sizes in testing at the moment, going from inshore boats, very small boats like the Corinthian up on the Gulf, fresher boats such as the Otakau, and factory trawler boats such as this Dakotas. That's a 64-metre boat, 40-odd crew. So at the moment, we've got tremendous results for low fatigue, high-quality fish to the back deck in Hoki and in Snapper. We've got selectivity designs in process and getting some very good results here now in the Snapper for our catch composition. We'll touch more on that in a bit. And our 3rd exemplar, which is squid, is due to start early next year. So we've also got in process design and development of our new handling systems. Just to look at where we've come from, this is the old mesh trawl, and the water velocity is basically going straight through the meshes. It's a mechanical sieving system where the fish have got velocity going across the mesh escapements. The mesh escapements are getting pulled tight, and there's a bunch of mechanics going on in here which are causing damage to the fish. We get good efficiency on our platforms, which we want to maintain. That's one of our areas. Well, we're not all longliners, but the results on the fish are reasonably tragic. We lose market value, and we get a reasonably bad rap for sustainability performance. So we're moving on from that. And this is one of our bags here being dropped into a pound on the back of a boat. As you can see, we're still very crude in terms of our handling systems. That's not ideal. But the fish inside the bag are being protected. It's a water-on-water environment. The interactions between the fish and the meshes is much, much reduced. And this, in essence, is the backbone of the technology. We're just reducing all the stresses and strains, and the fish are in a low fatigue condition. So when we've got that high velocity environment in a mesh trawl and the fish are being forced to exercise and swim against that current, they're losing a lot of energy in the flesh. And that flesh degradation gets picked up by consumers who know their seafood. It's one of the reasons why trawl caught fish is very rarely accepted into a sashimi market. But these fish, although being processed on a trawler, definitely have the potential to meet that upper echelon of quality. So it's tremendously exciting. It's one of the reasons that we're getting a reasonably solid core now of fishermen who are becoming converts and starting to share the same passion that we see in the science team. What's our process? So we've got 2 main areas of the program. One is Alpha, which is where the science team have their innovation. It's our innovation engine room, and they're allowed to go out there and test any crazy idea that they've got, and they've had some beauts. Not all of them work, and that's one of the reasons why we get a little antsy about putting all our results up in public. It can make you look a little bit crazy, but you need that innovation, you need that freedom to do that, to make sure that you're covering all the bases. Once we get an idea that looks like it's reasonably solid, we put it out onto the boats for the skippers to look at. And this is our beta, or our commercial testing. This is where the ministry observers get a look at it, and we're starting to collate data around the actual catch performance and catch composition that we're seeing in real life. Just to show how this is picking up, there was 2,500 tonne of Hoki landed in this side of the program just last quarter. So it's not just Mickey Mouse stuff, it's actually starting to take off. And the skippers are getting a much, much better feel. We're developing a good pattern of know-how now where they're starting to get some pretty solid working information or operational information about what they can and can't do with these new gears. So, the progress. Well, as I said, we've got a very good result now for low fatigue delivery to the back deck. And now the job is to capitalise on that. Our stage 2, which is the handling and grading and sorting systems, needs to be able to work in to capitalise on the opportunity that we've presented there. We didn't previously have that, so it's a great potential, and I can assure you the science team are not far away from bringing through to the testing phase some fantastic new technologies. The selectivity is an interesting one. If you look at that photo up there behind me, you can see that they've got a very benign, low-velocity environment. The fish are basically schooling. There's no sieving or mechanical work there. They're not being pushed to the back of the cod end like a normal net would be. So those are schooling fish inside the capture environment. And quite often the scientists have actually seen fish coming in through the sides of the trawl to get in there. Now that's thrown up some pretty interesting results for the science team to deal with in terms of the selectivity, and I'll cover those off in just a minute. Handling systems are coming through in a second stage, and we've just started now with the regulatory validation work. So part of the base we've been building was to ask ourselves the questions, what is the ministry going to look for in terms of regulatory approval, and then how could we bring those results through in a form that they would accept? And that's all done now, and now we start into the phase where we're actually going to do it. Brand development work is underway, and later this year we'll probably see quite a bit of movement in that area. Also to develop New Zealand as a leader in the world for this type of sustainability performance. So sustainability, we've got improved survival rates and unintended catch as our overriding sustainability goal in inshore fishing. And I was very pleased to see earlier, Pamela, your relationship there between reduced mortality and a pickup in the TAC. If we can do that for snapper, we're on a real winner. We've got two ways of hitting this problem. The first is to not bring the fish up at all, and that's selectivity. But selectivity is a whole bunch of stuff. So what we're seeing is that currently our design is slightly behind the commercial gear in terms of the number of small fish per catch that you'd bring to the surface. You think, oh, bummer. But what we see now through the video is that if that's a 1 metre difference between two runners at the end of a race, what we thought might be a big gap because it's a 100-metre race, actually it's a marathon. Both systems are highly selective, and it's screening a lot of small fish under the water, and we're just starting to get a handle on this right now. So the gap isn't as major as what we first thought. The second really pleasing thing is the method of escapement is hugely different, and we're starting to get a handle of that. But we need to give the MPI a measure. So we've picked this measure at the moment, which is the ratio of SNX to SNA. And right now we're about equivalent. So not better, not worse, but we're hugely inspired by what we're seeing in terms of the whole process, which is the way the escapement and selectivity work's happening. You can see why we're a bit shy about going public, because I'm talking to you as professionals in the industry, and I'm still not sure if I'm getting my point across correctly. But we're encouraged. The trick now is to show this in terms of a regulatory approval process in a way that everyone's happy with it. I'll deal with that a little bit say later on. Survivability, we're very excited about, and I'm going to move on to that now. So these were the results we put up in a very public show. We put a YouTube up. We put a bunch of scientists talking about it, and Susie and Alistair were involved in that. And we tried to give it as much context as we could. Now that, you know, the mainstream media that pulled this out, they showed that, and it's what we wanted. But in essence, this is only one part of the picture. What we showed is the potential survivability for the system. And really, I'm going to tell you right now that until the fish at the back end of a grading and sorting process for a 2-ton catcher hoki is the same as at the start of that process, we haven't achieved anything. And so we don't want to just say that we've improved the potential. We're working to get it right through so that fishermen at the end of the whole interaction of the fish with the boat and the net, have the same survivability at the end of that process as at the start. What we've done just now is shown that we've got a huge, huge gain in the survivability of the fish at the back of the deck. And we did that to show an apples with apples comparison of the mesh trawl against the modular harvest system. So this is a great thing for us, but we're a little bit worried that it might have been misconstrued. So massive gain in potential, but we've still got a lot of work to do to get that grading and sorting nutted out. But we're very close. Hoki is just a win-win-win. It's hard to keep Dorji constrained. Dorji wants to run the whole Sealord fleet on it tomorrow. As I said, 2,500 metric tonne was landed in the last quarter. Both Sanford and Sealord are looking at ramping up considerably over the next couple of quarters. So significant build program going on for getting the new modules onto the larger boats. The quality cascade gains are huge, and we're just looking at tremendous potential and very rapid. On the good news too is that in terms of the compliance and regulatory approval process, this looks to be something that is going to move ahead quite quickly as well. So Hoki is shaping up to be, as an exemplar species, a big winner. The regulatory approval process is tricky. So we're trying to knock over or change one of the tenets of the fishing industry, which is a regulation based on mesh size. It's not as easy, you know, you can have a lot of good information, good data, but it's not as easy as just knocking on the door of the ministry and saying we want to fish with something that's got no meshes. So we're currently testing under special permits. That's working very well. We've got a great working relationship with the ministry around this, and they're working very hard to let us grow the good news and keep developing these processes. But we're also trying to work out how we can bring trawl systems into play that have no meshes. And so this is the tricky bit. There's quite a few people working on it. We got invited to a delegation at the MPI a couple of weeks ago. We suddenly realised there's 30-odd people from policy, compliance, enforcement, the PGP team, and honestly it was a bit overwhelming actually to look at the number of people that were suddenly involved in changing these regulations. So a bit of an eye-opener for us, but the dialogue is very, very positive, and I think this area is going to move ahead quite quickly. And so now we've got the plant and food scientists and the MPI science team working together to work out make sure that the systems, processes, methodologies are all in line, that we can step ahead quite quickly on that. So in an overview, our two big goals, which is the value and the sustainability. Green is good and the pea soup's not as good as good. But if we look at snapper, the survivability, we're really chuffed with that. That we think is going to develop into a massive gain for the overall snapper fishery. And as we said, if we can reduce the mortality the same as Pamela showed us, and that will come through to the TAC, the whole industry is going to be a winner there. The seal activity is, well, we think it's really good, but the trouble there, why it's not a bright green, is that we need to work out exactly what we're showing in terms of our result. That's that SNX to SNA. It's a measurable outcome. We're not sure it's the whole story because of what we're seeing under the water, but we've got to sort of work out a way to bring all that information together. Hoki is a win-win. It's good in terms of what we see in terms of getting it across the line in the sustainability side. It's also excellent in terms of the value. And squid, well, that's just yellow because we haven't started yet. We had 2 attempts to get it going down on the east coast of the South Island. The squid didn't show up, and so now we're looking at getting it going in January next year. So we're standing here as a group, 3 years in, we're still all together, and yes, we are proudly trying to change the way the world fishes. So thank you very much for your time.